Hello everyone, in this video we're going to explore topic 4.1 interpreting the meaning of the derivative in context. In Unit 2 and 3, we extensively study the procedure for finding a derivative. Now in Unit 4, we turn our attention to what the derivative means in the context of a problem. Now let's take a look at example number 1. This question comes from the 2001 AP Calculus AB and BC exam. Question number 2. Alright, the temperatures in degrees Celsius of the water in a pond is a differentiable function W of time t. The table to the right shows the water temperatures as recorded every 3 days over a 15-day period. Now, question A. Use the data from the table to find an approximation for W prime of 12. Show the computations that lead to your answer indicate units measure. Alright. So basically, you look at the table right here, you see that 12 is between 9 and 15, right? So you remember the average rate of change you learned from AB pre-calculus, right? It's going to be f of b minus f of a over b minus a, right? Now we do exactly the same thing right here. It's going to be W of 20 equals 21 subtract 24, right? This one is a, this one is b, this one f of a, and this one is f of b, right? So it turns out to be 21 minus 24 divided by 15 subtract 9, right? So it's going to be negative 3 over 6, which is negative 0.5. And don't forget to include the unit, right? Now, what if we ask to interpret the meaning of the approximated derivative value we found in example number 1? Interpreting the meaning of a derivative in the context of the problem will certainly be a question you will encounter on the AB exam. The acronym NUT can help you probably answer this type of question. N stands for noun or number, subject of the problem, and the numerical value, right? U, which means units, label with the appropriate units, and T stands for time, include the time at which the derivative change was computed, right? Now question B, interpret the meaning of the derivative from part A in the context of the problem, right? So part A, we got this one right here, negative 0.5. We need to say the temperature of the water is decreasing because you have the negative side right here. This side tells us that it's going to be decreasing. If you see positive side, it's going to be increasing, alright? So keep that in mind. At a range of 0.5 degrees Celsius, at the time t equals 12 days, which is the one inside parenthesis right here, right? Sorry, this one should be 12, right? Alright, let's move on to example number 2. This question comes from the 2013 AP Calculus AB and BC exam number 2. On a certain work day, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equal 90 plus 45 cosine t squared over 18, where t is measured in hours and t between 0 and 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation t from 0 to 8, the plant processed gravel at a constant rate of 100 tons per hour. Now question A. Find G prime of 5. Using correct units, interpret your answer in the context of the problem. Right? Now, since this one is the calculator active problem, right? So we're going to bring up the calculator. And we need to calculate G prime of phi, right? And G of t is given right here. Now we have a ti and phi calculator here. Alright, so you're gonna add calculator here. Alright. Now first you're gonna store the equation. Alright. So in order to store equation, you need to hit G of t, right? And you hit control and this button right here. Alright, so you just input the value. It's gonna be 90 plus 45 cosine of t squared over 18. Then you hit enter. Done. Right? Now you're gonna hit menu, calculus, numerical derivative at a point. Right? Variable right here in this situation. You're gonna put t. Right? The value right here should be phi. Right? And then this one is first derivative. Hit OK. Now you just input g of t, right? And then you hit enter. The answer is negative 24,587, right? Alright, keep in mind the original function g of t right here, the unit is turns per hour. When it's come to the rate, you need to put another per hour. So you have 2 per hour right here, so be careful. Alright. Now we need to interpret a second derivative in a context. We look at this one right here, we see that the rate at which the gravel is arriving is decreasing because you have the negative side right here, right? At a rate of 24.587 tons per hour square, right? You have 2 hours right here, you see that? So it can be hour square, or you can write tons per hour, they're both the same, right? Now keep in mind, when you write at a rate of, don't include the sign, right? No negative, no positive right here, right? Because you will say decreasing right here, right? At the time t equals 5 hours, right? 5 hours, 5 right here, right? Now let's move on to the last question. Example number 3. This question comes from the 2007 AP Calculus AB exam from B question 3. The wind chill is the temperatures in degrees Fahrenheit a human feels based on the air temperatures in degrees Fahrenheit and the wind velocity v in miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by W of V equals 55.6 minus 22.1 V raised to the 0.16 and is valid for V between 560. Now question A, find W prime of 20. Using the correct units, explain the meaning of W prime of 20 in terms of the wind chill. Alright, so again, we're going to bring up the calculator. We need to solve the equation right here. WV equals 55.6 minus 22.1 V raised to the 0.16, right? So it's going to be, now you're going to hit menu, calculus. Number 1, the variable in this situation is V. The value should be 20. And then this one is the first derivative, right? And then you just put W of V and hit enter. The answer is negative 0.285, right? We need to explain the meaning of W20 in terms of the wind chill. So we need to say the wind chill is decreasing because you see the negative side right here, right? By a rate of 0.285 degree per mile per hour at the wind velocity V equals 20 miles per hour, right? To use the TI-84 plus C calculator to do this problem. Alright, so you're going to hit math. Alright, you scroll down until you see the derivative right here, number 8, right? Hit enter, right? Now, The variable in this situation is v, right? You just put s, right? And you just change every single thing to s, right? And you just enter the function right here. So it will be 55.6 minus 22.1. And then you put s right here, raised to the 0.16, right? And then you need to put the s value right here. It should be 20, right? And you hit enter, you still get the same answer, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.